This video, we're going to talk about techniques for evaluating limits. First thing we need to go over is a few things. If you have the number 0 and you divide it by not 0, what do you get? Well, just like 8 over 2, if you wanted to figure out what this equals, you can ask yourself 2 times what equals 8. The answer is 4. And if you have 0 over not 0, you can ask yourself the same question. 7 times what equals 0? The answer is 0. In fact, that's the only answer. If you multiply two numbers and none of them are 0, well, the product will not be 0. If you have 0 over negative 2/3, that's 0, because this non-zero number times 0 is going to equal 0. If you have 0 over the square root of 11, that's 0. Because if you multiply two numbers and you get 0, one of them or both have to be 0. That's not 0. So this has to be. There's no way out of it. If you have 0 over 0.314287, this is going to be 0, because this number times only 0 will give you 0. This is always going to be 0. If you have not 0 over 0, you will get 0 every time. Well, what if you have not 0 on top, but 0 on the bottom? What will this equal? Well, if you have not 0, 8. 8 over 0. Well, 0 times what number gives you back 8? And the answer is no number. Because if you, no matter what number you put here, when you multiply it by 0, one of those two numbers are going to be 0, namely this one, for sure. And when you multiply these two numbers, you're not going to get 8. If you have 17 over 0, no matter what number you put there, when you multiply it, you're not going to get 17. You're going to get 0. Once again, there's no number to put there. It's undefined. This is why you keep being told you can't divide by 0. The top number is not 0, and you divide by 0, it's said to be undefined. Call this 1, 2, and 3 is going to be when the top and the bottom are 0. What does this equal? Well, if you have 0 over 0, let's see, it can equal 0. After all, 0 times 0 equals 0, but it can also equal 11, because 0 times 11 equals 0. It can equal negative square root of 3, because 0 times any number, including negative square root of 3, will give you 0. It can be negative 2/3. 0 times that number is 0. It can be pi. 0 times pi is 0. So it seems like 0 over 0 can equal to any number. But that's going to create problems. Because, for example, 0 over 0 can equal 1, and 0 over 0 can equal 8, plus many other values. So 5 is equal to 5 times 1. Nobody would argue that. And if we allow 0 over 0 to be any number we want, it can be 1. So here's 5 times 1, which is 5 times 0 over 0 can be 8. Can be any number. So 40. So what we have is that 5 equals 40. But we can't have this. If you borrow $5 from your friend, and your friend says, don't worry, just pay me back next week, no interest, no anything. And then next week comes and your friend asks for $40. And your friend said, wait a minute, they're equal, they're the same. I want $40. I mean, it's the same as 5. We can't have this. This is nonsense. We can't determine what 0 over 0 is. So, we call it indeterminate. With respect to limits, whenever you get 0 over not 0, you're done. The limit is 0. Whenever you get not 0 over 0, you're done. It's undefined. Whenever you get 0 over 0, which means indeterminate, you need to do something to determine it. And if, of course, and this is after direct substitution. That is, after direct substitution, you get 0 over not 0 over 0, or 0 over 0. And the fourth case is if you get something like 7 over 8, you're done, unless, that is, top and bottom are not 0, unless it can be reduced. If you have 7 over 8, you're done. If you have 12 over 8, you should say that's 3/2. Okay, up to reducing, when you directly substitute, you're immediately done unless you're in case number 3. Case number 3 is the one where you need to do more work. Otherwise, direct substitution, that is fine. Okay, let's get rid of this. Now, let's suppose the following. Let's look at this limit. Suppose you have the limit as x goes to 3 of 2x minus 6 over 7. Lots and lots of people will say, first thing you do when you have a limit, you factor. Nonsense. That's really not good advice. I'm just going to write that symbol for x. So 2 times x minus 6 over 7. This is 6 minus 6, which is 0 over 7, which is 0. I'm done. Now, if you have the limit as x goes to 5 of x plus 2 over x minus 5, you directly substitute 5 for x, so x plus 2 over x minus 5. I get 7 over 0. The only difference is I'm not done here. I just have to write undefined, and then I'm done. That's the answer. Here's the answer. This here is not the answer. Just say 7 over 0 is undefined. If you have the limit as x goes to 3 of x squared plus 3x over x squared plus 5x plus 6, you can factor all you want, or you can say 3 squared or x squared plus 3 times x over x squared plus 5 times x plus 6. 9 plus 6, 15. 9 plus 6, oh, okay, let me try that numerator again. That's 9 and that's 9. That's 18. 9 plus 15 plus 6. 9, 15, and 6. 15, 5, 20. Looks like 30 to me. Oh, I can reduce this. Both of these numbers are on the 6 times table. I divide the top number by 6. I divide the bottom number by 6. And before I say that that's the answer, I look to see if I could reduce more. Maybe a larger number than 6 went into those numbers. Okay, so that's the answer there. So now, I want to point out something that I did in my last video. And a lot of people are going to say, no, this is not right. It's not what I was taught. But if you think about it, what I'm saying is 100% right. Okay. X divided by X is not 1. It is not 1. Usually it's 1, but there's at least one time where it is indeterminate. As long as it's not 0 over 0, you divide the same two numbers, you get 1. Well, it's going to be 0 over 0 when X is not 0. And it's going to be 0 over 0 when X is 0. This here is a piecewise function. Like if I asked you to graph this, for most values it's 1, except at 0. X, Y, this is the line y equal to x over x. It is not the line x equals 1. Because if x over x equaled 1, then I would have drawn the line x equal 1. And if I do that here, if that's y equal 1, it would have been that. Okay, a little bit higher. It'd be there. But we didn't get that. We got a hole right here. Okay, that's because x over x is not always 1. Same argument. If you have x minus 7 over x minus 7, as clear as day, you're dividing the same two things. These are both the same. So you'll get 1. Not always. Not when it's 0 over 0. A lot of students will say, oh, so x can't be 0. No. If x is 0, the top will be negative 7 and the bottom will be negative 7, and you divide, you get 0. I mean, you get 1. But if the top is 0 and the bottom is 0, you won't get 1. And that happens when x is 7. So I won't let x be 7. But when x is 7, it's going to be indeterminate if x is 7. Okay. So this should help us in the next problem. We have the limit as x goes to 5 of x squared minus 25 over x minus 5. If you substitute, you get 5 squared, which is 25 minus 25. That's 0. And in the bottom, 5 minus 5 is 0. Okay, here maybe factoring would have helped. But many times, you'll just get 7 over 9, and there was no need to factor. Okay, but let's be very clear. If you get 0 over 0 by direct substitution, it means that you have to do something. Somehow you want to cancel out 0 over 0. Now, if 5, now the top and the denominator are polynomials. If 5 made the top 0, that means x minus 5 must be a factor. This is from pre-calculus. The other factor happens to be x plus 5. In the bottom, since 5 made it equal to 0, one of the factors must be x minus 5. In fact, it was the only factor. Now here's the beautiful part. This over this is 1. Why? Because x will never be 5. So basically, we just have the limit as x goes to 5 of 1 times that, which is just that. And now when you substitute in 5, you get 5 plus 5 equals 10. Oh, by the way, here's where we crossed off 0 over 0, like I said. And there may be times where you'll have to cross it off a second time and a third time. But eventually, you won't have 0 over 0 anymore. And in this case, 0 over 0 actually equaled to the number 10. Let's look at this problem. Suppose you have the limit as x approaches -1 of x squared minus 2x minus 3 all over 4x plus 4. Well, let's plug in -1. So it's x all squared minus 2 times x minus 3 all over 4 times -1 plus 4. So -1 squared is 1. -2 times -1 is plus 2. That's 3. Take away 3 is 0. This is -4. You add back the 4, you get 0. That means you have to do something. Again, since the top and the bottom are polynomials, x minus -1, better known as x plus 1, must be a factor. When you factor the top, you get x plus 1. And the only way you're going to get an x squared and a -3 is to put an x. That'll give you the x squared, and you put a -3, and you'll get the -3. Okay, so x plus 1 times x minus 3. X plus 1 times x minus 3. In the bottom, you can factor out a 4, and then you have x plus 1, and that can't be factored. But as promised, look at the bottom. It has a factor of x minus that number. Okay, now the only time this is not 1 is if this is 0. And that happens when x is -1. X will not ever be -1. So I can cross it out. So I'm left with the limit as x goes to -1 of 1 times that over 4. And now when I substitute in, I get x minus 4 over 4, which is -5 over 4, and that cannot be reduced. You might be able to write it as a mixed number, but I never said that before. I just said that you have to reduce it. Don't have to write it as a mixed number unless your teacher makes a big deal out of that and says write it as a mixed number if you can. Next problem. You have the limit as x goes to 4 of 5 times x minus 4 all over x squared minus 8x plus 16. If you directly substitute, you get in the brackets x minus x, 5 times it, x squared minus 8 times x plus 16. This is 5 times 0. This is 16 plus 16, 32. 16 plus 16 is 32. Minus 8 times 4, which is 32. Oh, we get 0 over 0. Okay, that means we have to do something. We have to cancel out 0 over 0 somehow. Well, again, the top and the bottom are polynomials, and if that number makes the top 0, then x minus 4 must be a factor of the top. And yeah, that was pretty clear. And in the bottom, one factor will be x minus 4. It turns out that the other factor will be x minus 4. Now, the reason we got 0 over 0 was that when you plugged in 4 for x, that piece was 0 over 0. But now we can cross it out as if it's 1. So the limit, it becomes the limit as x goes to 4 of 5 times 1, which is 5, over x minus 4. You plug 4 in for x, we get 5 over 4 minus 4, which is 5 over 0, and just one more line. That limit is undefined. Okay, and that's your answer. This limit way up here, which equals to this, which equals to this, which equal to that, which equal to all of this, which equal to this, which equal to that, which equals to this, equals undefined. That means the beginning is undefined. Put your equal signs. They're very, very important. Now, suppose we have this limit. The limit as x goes to 25 of the square root of x minus 5 over x squared minus 25. So you get the square root of x is 25, minus 5 over 5 squared minus 25. The square root of 25 is 5, minus 5 over 25 minus 25. This is 0 over 0. So we have to do something. Problem is that the numerator is not a polynomial. So we need to figure out how to cancel out x over x. So this is equal to the limit as x goes to 25. Now the bottom I can factor is x minus 5 times x plus 5. And the top I can factor. But I have to do something because I have this 0 over 0. So I can multiply by 1. I'm going to multiply the numerator by the square root of x plus 5. And of course, I have to do the same to the bottom. Remember, whenever you have a minus b times a plus b, you're going to get this squared minus that squared. A squared minus b squared. Well, if that's a and that's b, a minus b, well, that's the same a, that's the same b, and now we're adding, so we're going to get the limit as x goes to 25, and we're going to get a squared minus b squared. A squared is x, b squared is 25, all over the square root of x plus 5. Now, if I plug in 25 for x in here, I get x minus 25 divided by, something's bothering me, excuse me. We didn't write down the whole denominator. Very sloppy. The numerator, so we have the limit as x goes to 25. The numerator becomes x minus 25. And the denominator is this times that. It's x minus 5 times x plus 5 times the square root of x plus 5. Okay, let us see what we get when we plug in 25 for x. Okay, so Dawn, from the very, very, very beginning, that should have just been x. That should have just been x. And x is 25. So I am getting 0 over 0. So we need to do something. Sorry about this error. This is equal to the limit as x goes to 25 of the square root of x minus 5 over x minus 25. I'm going to multiply this by the conjugate of the top and bottom. Otherwise, what's in these brackets will not be 1. So I have the limit as x goes to 25. Keep writing limits until you substitute 25. The top is going to be x minus 25. The bottom is going to be this times that. X minus 25 times that. Now, the nice thing is that as long as x is not 25, and it won't be, this won't be 0 over 0. So we get 1. So we have the limit as x goes to 25 of 1 over the square root of x plus 5. So we get 1 over the square root of 25 is 5 plus another 5. We get 1 over 10. Now, I'm going to do this same problem over, but this time I'm going to do something to the denominator. You decide which way you like better. And the limit is x goes to 25 of the square root of x minus 5 over x minus 25. Now, I claim that the denominator is the difference of squares. The 25, that's pretty clear to be 5 squared. And the square root of, x, that's the square root of x squared. So we have the limit. By the way, we know we're getting 0 over 0 because we learned that from the same problem up here. So the top is square root of x minus 5, and the bottom is the difference of squares. If square root of x is a, we have a squared minus, and if b is 5, well, this becomes a plus b times a minus b, where a is the square root of x and b is 5. So we get a plus b times a minus b. Now, if x is 25, then this will be 0 and this will be 0. But only when x is 25. But x is not going to ever be 25. Gets as close as imaginable, but it won't be 25. So this is 1. So then we have the limit as x goes to 25 of 1 over the square root of x plus 5. But this is 1 over 10 because you get the square root of 25, which is 5, plus another 5. So we did it 2 different ways. We got the same answer. In the first case, we simplified, or we changed the way the square root of x minus 5 looked like. Because I took the square root of x minus 5, I multiplied it by this, and then it came to be x minus 25, which was one of the factors in the bottom. Okay. In the second way, below this line, this time I took the bottom. The top stayed the same, square root of x minus 5. But the bottom, I factored the bottom. Okay, you're gonna have to be able to do that. You will see problems just like this. All that will change or will be these two numbers and that number. But they're going to make things become 0 over 0. Okay. How about you have the limit as x goes to 4 of 2x minus 8 over the square root of x minus 2. 2 times 4 is 8, minus 8, that's 0. And then the square root of 4 is 2. Square root of 4 is 2. 2 minus 2 is 0. That means we have to determine what this is. Limit as x goes to 4. So now what we have is this. We have the limit as x goes to 4. Let me factor out the 2 from the top. Oh, look at that. 4 made the top 0. X minus 4 was a factor. And in the bottom, we have the square root of x minus 2. Well, you know what? If I squared this whole thing, I get x minus, and if I squared the 2, I'll get 4. Oh, that's exactly what we have on the top. So what I am going to do is I'm going to multiply the bottom by the conjugate, because that would mean that the bottom is going to become x minus 4. But if I the only thing I can multiply what's in here by is 1. Otherwise, I changed its value. The bottom has to be square root of x plus 2. Well then, so has the top. Okay. So now the top, I just multiply across. 2 times x minus 4 times the square root of x plus 2. Got lucked out that I left a lot of space here because I need to write the limit as x goes to 4. Now, the beauty of this is since x is not going to be 4, that cancels out. So I'm left with the limit as x goes to 4 of 2 times the square root of x plus 2. This is 2 times the square root of 4 plus 2, which is 2 times 2 plus 2, which is 2 times 4, which is 8. As x gets really, really close to 4, this gets close to the number 8. If you want to check if you're right, if you ever want to check if you're right, close to 4, say 4.0001, okay? So compute 2 times x minus 8 all over the square root of 4.0001 minus 2, and you will get amazingly close to 8. I'm not promising it's going to equal that, but put a question mark there. But you're going to get a number close to 8. You know, maybe this is 0 and then you have 0, 3, 4, 1. But it's going to be close to 8. Whatever you get, it's going to be close to 8. And in one of the later videos where we do epsilon delta proofs, we'll show that you can get as close to 8 as you want by making this number closer and closer to 4. Of course, you could have plugged in 3.9999 in here and in here instead of 4.001, and you would have gotten approximately 8. So you can always check your limits. Like during an exam, you can use your calculator. Plug this in for x into here, and you should get really close to whatever you claim the limit is. Now, if over here you're getting about 18, and you didn't make any mistakes, so check to see if you got this number correctly. That is, if you did this correctly. And if you did, Maybe check it a second time. But one of these is wrong. Either your evaluation at 4.0001 is wrong, or you made a mistake on the limit, because these are supposed to match. And I'm sure that they will. That's going to be around 8. Okay. Let's talk a little bit more. Suppose you have this graph. This is the y-axis. That's the x-axis. And the graph goes like this. This is x equal 4 right here. Here it's 1, 2, and then 3. Now we're going to talk about left-hand and right-hand limits. And let's call this function g of x. What is the limit as x goes to 4 on the left, to the left? This does not mean minus 4. That minus up there means to the left of, in this case, 4. If I had written the limit as x goes to negative 4 with a minus up here, it's x is getting close to x is getting close to negative 4, but from the left, a little bit less than negative 4, a little bit to the left of. Okay. I want to know what that limit equals. This limit of g of x. I want to know what this limit equals. This means to the right of 4, getting really, really close to 4, but from above 4. We're going to, maybe it's going to be 5, and then 4.9, and then, 4.1. I ran out of room, please. And then 4.01, and then 4.001. And and so on, where eventually we get to 4.25 zeros and then a 1. We're getting closer and closer to 4, but all the numbers are bigger than 4. That doesn't mean we can't be getting smaller and smaller. We're just always above 4. I want to know what that limit is. And then I want to know what the limit is of g of x at 4. No plus or minus sign up there. What is that limit? And then I want to know what g of 4 equals. Okay. Well, if you come from the left of 4, that x value is less than 4. That's a little bit closer to 4. Closer to 4. I mean, I admit we're nowhere near 4 yet, but we're getting there. Okay, we're getting closer and closer to 4, and the y values are getting closer and closer to 1. Okay, now I'm supposed to get closer to 4, but from above. I should be above 4. That x value is more than 4. That x value is more than 4, but it's closer to 4. This x value is closer to 4. 4, getting closer, really getting closer to 4, very close, insanely close, really close. And it looks to me like we're getting closer and closer to 3. Now here's the game. Since those numbers are not equal, this tells us that the limit as x goes to 4, no plus or minus, of g of x does not exist. For this type of limit to exist, where you don't have plus or minus, the left-hand limit, this is called a left-hand limit. Why? Because we're coming from the left of 4. Now here's the hard part. Drove me crazy as a student. We're coming from the left of 4, but you know what? We're moving to the right. I admit we're moving to the right. So what is this? Left-hand limit? We are approaching 4 from the left. First we're here, and then 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 here. We're moving to the right, and we're getting closer to 4 from the left of 4. Okay. And down here, this is called the right-hand limit. Okay. So we already talked about this. It does not exist. Now, what's g of 4? Well, if you want to find g of 4, you go to 4 and you look straight up until you hit the graph. And if you have to go further down, go down. And if you hit the graph, now we do not, this pink line did not hit the graph here, because that point is not there. But it hit it here, and all I do is I look across and I say, oh, g of 4 is 3. G of 4 equals 3. Okay? Now, we really haven't talked about, we computed limits already, and we never talked about left and right hand limits. Well, the only real time you're gonna get different answers is if they're like two different functions. They jump. This graph is up here and this graph is way down here. There's this gap in between. And the graph is screaming, hey, I have a gap, I have a gap. So maybe the left and right limits won't be equal. Let's try this problem. Suppose you have a function. Let me move this over to save some space maybe. Suppose you had a function that goes like this. 1, 2, 3, 4, 5, 6. The name of the function is f of x, and this x value right here is 3. What is the limit as x goes to 3 from the left of f of x? What is the limit as x goes from 3 to the right of f of x? Based on those two answers, tell me if the limit as x goes to 3 of f of x exists. And lastly, what is f of 3? Okay, so this tells me I get closer to 3, but I'm always a little bit less than. That is, I'm around here, and the y value around here, the y value around here is 1. Little bit more than 3. The y value really, really close to a little bit more than 3. That's 1. Since they're equal, the limit as x goes to 3 with no plus or minus of f of x is that common answer. Now f of 3, well, you just look up and down from the line x equals 3. And it, excuse me a moment, it only crossed the graph right here. Everything in green except the point in that circle. Everything in green, and I mean everything in green, is part of the graph. You have this part, you have this piece, you have this point up here, and right here, Even though I have this big circle there, there's nothing there. Don't see green. The only place this pink line crossed was right here. It only crossed right there. And that is when y is 6. So f of 3 is 6. Notice, it didn't equal the common limit. It didn't equal 1. It could have, but it didn't. Remember, the limit doesn't care what happened at 3 itself. The limit doesn't care about what happens at 3 itself. At 3, the function value was 6. The limit was 1. They're not the same statement. Let me show you an example of that. Suppose that you have f of x is equal to x squared minus 25 over x minus 5. And I want the limit as x goes to 5. Okay, that is, I want the limit of this function, x squared minus 25 over x minus 5. Well, if you plug in 5 for x, you get x squared minus 25 over x minus 5, which is 25, that's 5 squared, minus 25 over 5 minus 5. Oops, 0 over 0. I have to do something. So this is equal to, the limit is x goes to 5. I'll factor the top. I get x plus 5 times x minus 5 over x minus 5. Since x will never be 5, I can cancel this out. And what I get is this. And this happens to be 10. Now, what did we really discover? We discovered that this here is a piecewise function. Most times it's x plus 5 because it's always this. It's always that. All I did was factor the numerator this way. It's always that. And as long as x is not 5, this always cancels out, and you're left with just x plus 5. But now, when x is 5, it is indeterminate. Well, how do you graph x plus 5? Well, the y-intercept is at 5, and it has a slope of 1. That's the graph of x plus 5. The graph of this, the only difference is that when x is 5, we erase that little point. We erase when x is 5. Put an open circle there. But that open circle is getting really close to 10. It's getting really close to 10. If I'm a little bit less than 5, f of 4.999 is close to 10. And if I'm a little bit above 5, f of that number is a little bit bigger than 10. It's narrowing in on 10. Getting closer and closer to 10. Not sure why I put a 5 up there. Oh, that was for the y-intercept. Okay. This function and this function, f of x equal x plus 5, they're exactly the same function, except at 5. This one at 5 gives you 10. This one at 5 says, I don't know, it's 0 over 0. Okay. But in the limit, this is going to be 1. It cancels out. Okay, let us do one more problem. suppose we have a graph like this, except that point right there is not there. There's no point there. That's at x is equal to -2. This is 1. The name of the function is f of x. And same 4 questions. What's the limit as x approaches -2 from the left of f of x? What is the limit as x approaches -2 from the right or above? What's the limit as x approaches 2 of f of x? And how much is, -2. And how much is f of -2? Okay. 4 problems. 1, 2, 3, 4. First problem. What does this equal? What happens when I'm not at -2, but I'm a little bit to the left of -2? I'm like right there. Well, the y value is going to be really close to 1. And that's the answer. What if I'm not -2, but a little bit more than -2? Like right here. Well, this time I'm going to be a little bit lower. I'm going to be just below 1. Okay, just below 1 for limits is 1. What's the limit? Well, since these two answers were the same, then the limit, the one that doesn't have any plus or minus here, is equal to that common answer. If these two numbers were different, then we say does not exist. But they were the same, so we put down that common answer, 1. Now, what is f of -2? Well, I drew on the graph a little bit. Let's get rid of it. Here is -2 in a circle. That's the graph we were given. Well, I can look at -2. I can look up all day. I can look down all day. It's not hitting the graph. It's not hitting the graph. The graph is only what's in green. This green is not touching that blue anywhere. I mean, if I drew this line when x is 3, then yeah, the y value will be whatever number happens to be there. Okay, I mean, if this was 1, maybe that's 2, and that would be 3. Okay? So f of 3 would be 3. But we don't want to know about f of 3. We don't want to know about f of 3. We want to know about f of -2. And this green curve is not crossing anywhere when x is -2. Okay, that is why it is undefined. Okay, if I put a dot somewhere, it would be defined, but we never did. We never did. It is undefined. That completes this video on techniques for evaluating limits.